In this video, I'll cover some of the most basic circuit variables that we will be utilizing throughout this course. Specifically, I'll cover current, which we usually denote it as I, the voltage, denoted as V, and we'll talk a little bit about power, which is P. So let's get started with current. So what is current? Well, at its most basic electrical quantity is typically a charge, and a current is simply just the movement of that charge within a conducting medium. And mathematically speaking, we can define it as I as a function of t is simply the change of a charge within a time. However, for the purpose of this particular course, we do not care about this particular mathematical definition. And the reason why is we will abstract this idea and we'll think about current in a little bit of a higher level as a current flowing through a medium, and that's about it. So in here, I'm showing you a diagram of some sort of an electrical element, this one here. And typically, this electrical elements have what we call terminals. In this particular diagram in here, I'm showing you an electrical element with two terminals. And it doesn't matter what's inside it. I'm just basically defining it as a black box at this point. What matters to me in here is I'm going to define that there's a current flowing through this particular element. All right, so typically we say, okay, we have a current and that current is I, and typically we say, well, its value is 5 or 6 or whatever that number is. And that's basically the amount of current that is flowing through this element. However, there's a little bit more to it. So the first thing you need to specify is the unit for current. And typically current is in amps or amperes, or milliamps, microamps, and all the deviations or variations of amps. But typically we call them just amps A. Okay, so that's the first thing. The second thing, and it's really important that we define it, is when you define the current, it's not enough to tell me how much current is flowing through this terminal. You also have to tell me the direction at which this terminal or this current is flowing through this particular element. So usually we define it with a little arrow. So what this arrow tells me is the following, is I have current that is going from this particular terminal all the way through the box and out of this particular terminal in here. So this is the direction of current flow. And that's here, usually we denote current as I, and we say this particular current is, let's say 5 amp, and it's going from the top all the way to the bottom. So this is how we're going to think about current in this particular course. Of course, this particular value could be also negative. So for example, if I told you, well, this current in here happened to be negative 5 amps. That's okay. The negative just tells me that the current assumption or the current direction that you're actually looking at in here has been just wrong. That really the current is flowing from the bottom all the way to the top. That's what it tells me. But just to give you a hint, throughout this course, it doesn't matter if you get that negative. You just keep it and keep the assumption so that you do not lose track of it. And I'll cover it through or using examples later on. All right, so that here covers what current is. However, before I move on to the next idea, I want to make sure that we cover this particular concept, which is direct current and alternating current. So we will start the course with talking about direct current. So what's a direct current? Direct current tells me that the current is stable with time. So if I'm showing you a graph of time versus current, and a current is a function of time, you will see that the current value is just specific and it's just constant. And for example, in this particular case, it's 5 amp, and it doesn't matter what time it has been or has passed already. However, we do have some other currents, and specifically alternating current that actually alternate with time, like with a sinusoidal wave or maybe different shapes. And at the beginning of the course, we will not deal with these particular currents, just because the way we actually analyze circuits is simpler when we deal with DC currents, and we can expand these ideas that we cover using direct currents or DC to AC currents. All right, so to recap, whenever we define a current, we usually define a direction that the current is flowing and a value for that current. And of course, with the value, we associate some sort of a unit. All right, so move on to the next idea or the next circuit variable, and that's voltage. So what's a voltage? Well, the voltage is just the energy required to move from a unit charge from one place to another. Again, it has a mathematical definition. I can write it for you here, and that mathematical definition tells me that, for example, a voltage difference between 2 points A and B is simply the amount of work necessary to basically move a charge. Again, I do not care about this particular definition, even though it's correct, because for our purposes, for circuit analysis, we're going to abstract this idea and we're going to just think about voltage. So similar to current, we're going to think about a terminal or an element that has a couple of terminals, and we're going to define what voltage is or how do we use voltage around it. So if I call this particular terminal A and this particular terminal B, I usually can tell you, well, the voltage difference between A and B, maybe it is 6 volts. Okay, again, it's like also voltages have units similar to currents. We have a number or a value or a magnitude, and that's 6 in this particular case. And we have V, that stands for voltage, and of course we have microvolts, millivolts, kilovolts. We have all these variation of volts, but volts is the unit. I'm just going to write it in here as well for you. So similar to current, it's not enough to show me the amount or the magnitude of the voltage. You also have to tell me the polarity in the case of voltage. So in the current, you showed me, well, the current is flowing through this particular black box or this item from terminal A to terminal B, and you showed me a direction. In this particular case, what we have to show is the polarity. And typically we specify, for example, this is positive and this is negative. And in this case, we're saying that terminal A has higher voltage than terminal B, and if that particular sign is correct and everything is correct, you tell me that terminal A is 6 volts higher than terminal B. That's what you're telling me. Of course, we can have, similar to current, we can have negative values in here. For example, you can tell me, well, the voltage happened to be negative 6 volts. What effectively you're telling me is really B is higher than A by 6 volts. And that negative here is telling me that your assumption that this is higher than that is just wrong. Again, throughout the course, we will get negative numbers and positive numbers, and we'll have polarities, assumptions, and so forth. We typically stick to one assumption. So if you assume that A is higher than B and just happen to get a negative number, you just, whenever you want to use this particular voltage, you just assume that A is higher than B, and then you substitute that number with a negative. Just stick to these, and that's about it. And again, if I look similar to current, we do have alternating current or AC and DC, AC and DC in here. So we will start again by dealing just with DC current. So in this particular case, if I say this particular axis is for time and this particular axis is the volt, and how does it change with time, you will see for DC current, it's actually just constant. And in our particular case, if we remove that particular negative in here and we say it's just 6 volts, that will be the 6 volts and it's constant with time. However, we do have alternating current or AC, and you'll see that the voltage actually changes with time in a specific shape. It could be sinusoidal or anything. Again, for the purpose of analysis, and we will start just with DC circuits, it's just because the math is a lot easier when we deal with analysis of circuits that are only DC. And it just gets more complicated with AC, but the concepts are the same. The last circuit variable I want to cover is power. So it is not enough to just specify current and voltage when we do circuit analysis. We typically need power, and power by definition is just the rate of change of energy with time. Again, it has a mathematical definition that I will not worry about at this point. What I will actually take a look at is what the definition of power here is, or how we use it in circuit analysis. So typically we say the power is simply multiplication of the voltage times the current. That's basically how we look at it. And it usually has a unit, and that unit is typically watts, microwatts, milliwatts, and all the variation of watts, but typically it's watts. And that's the only thing I'm going to think about in terms of power. And typically we say an element is actually absorbing power if we figure out that the power value that we get is greater than 0. So that's basically, I'm going to write it as absorb power. And if power happen to be, or the magnitude that we get is less than 0, we say that this particular element is actually supplying power or generating power. Okay. All right, so let's take a look at the simple example in here to see how we can compute power. So we have, again, some sort of a basic ideal circuit element, and in here I'm going to specify a couple of things. I'm going to specify a voltage, and of course, when we specify a voltage, we have to specify that we have a negative and a positive terminal, and we're going to specify that the voltage value happened to be 2 volts in this particular case. And I'll also say, well, I have a current, and that current happened to be basically leaving that positive terminal in here. That's the direction, so that it's going from down all the way to the top. And this particular current is actually just 5 amps. All right, so in order for me to compute the power that is being generated used or generated in this particular terminal, we have to do the following. So we're going to do P is simply V, which is 2 times 5, and I'll get 10 watts. All right, so this particular element, as whether absorbing or supplying, I'll talk about in a minute, is just basically there's 10 watts associated with this particular element. But as you can see, in this particular example, what we did is we specified the voltage, and this is the polarity, and I told you that the voltage is positive. Okay, that's 2 volts in here, and I also told you that the current is 5 amps, and it's also positive. That means that my assumption for the voltage, polarity, and for the current directions are both correct. All right, so when I computed the power, I had to multiply 2 times 5. and I got 10. So anytime I'm actually multiplying voltage and current, I will get a positive number. That means everything is absorbing power, and that doesn't make sense. And as it turns out, that I'm actually missing something. When you compute power, you have to actually specify something else, and that something else is what we call a passive sign convention. So you have to put a negative here or a positive here, depending on certain conditions. In this particular case, it just happened to be that the current here is actually going to the negative terminal. So what you have to do is go and put negative here and negative here. So this particular element is actually generating power, okay, and specifically negative 10 watts. And the way I figure out whether it's negative or positive is what we call a passive sign convention, which I will cover next. But if you think about this in here, it's similar to a battery. If you think about it in here, in a battery, we know that the current is going out from the positive terminal, and that's basically what's happening in here. I have a positive terminal. You can think about this as maybe a AA battery or a AAA battery, whatever it is, and you're going to see that the current is moving from the positive terminal all the way to some other part of the circuit and going back from the negative terminal, and that's why it's generating power. So let's talk about passive sign convention to figure out where to put negative and where to put positive.